tutorial series of the wireless communication. I am your instructor Varsha Tak. Let's start our today's lecture. So at the end of this video, you will be able to learn about the CSMA protocol. Okay, so let's start with the our lecture with the CSMA protocol. So first is, what is multiple access protocol? Okay, so first of all, before starting the CSMA protocol, we should have to learn what is multiple access protocol. So when a sender and receiver have a dedicated link to transmit the data packet, the data link control is enough to handle the channel. Okay, so suppose there is no dedicated path to communicate or transfer the data in between the two devices. So what will happen in that case? So in that case, multiple stations access the channel and simultaneously transmit the data over the channel. Okay, so it may create the collision and the crosstalk. Maybe you have suffered from the crosstalk whenever you are calling to your friends or relatives, etc. Hence, the multiple access protocol is required to reduce the collision and avoid the crosstalk between the channels. Now, let's see for the example. Suppose that there is a classroom full of the students. Okay, so when a teacher asks the questions, all the students, that is what a small channel we can consider, in the class start answering. So the question at the same time, so the transferring the data simultaneously. So all the students respond at the same time, due to which the data is overlapped and the data is lost. Teacher may not be able to understand what the students are telling. Okay, so this teacher should have to listen the students one by one only. So therefore it is responsibility of the teacher. That is what the teacher, here we can see the multiple access protocol. Okay, so here the teacher is play the role of the multiple access protocol to manage the students and make them to answer one by one. Got it? So this the example we can take to understand why the multiple access protocol is required. Now let's see. Multiple access protocols can be broadly classified into three categories. Now which are these three categories? Okay, so first is the random access protocol, controlled access protocols, and channelizations protocol. So here there's a characteristic that this criteria is given to you in which type of this characterization is done. So first is what the random access protocol, then the control access protocol, and then channelizations methods, or we can just say the channelization protocols. In random access protocol, Aloha is there, CSMA, Carriersense multiple access is there, CSMACD, that's Carriersense multiple access with the collision detection, and CSMA, that's CSMA with the collision avoidance. Okay, so these are the four types of random access protocols are there. Then controlled access protocol, in which the reservation is there, polling is there, then token passing is there to get the chance to transmitting the data in the network. Then in the channelization method, FDMA, DDMA, and CDMA is there that we have already learned. Okay, now let's see this CSMA protocol. So first let's start with the Carriersense multiple access. So it is a Carriersense multiple access that is based on the media access protocol to sense the traffic on the channel, that is whether the channel is ideal or whether the channel is busy. If the channel is busy, the station will not send the data. But if the channel is free, then station will send the data. Okay, so before transmitting the data, it means that if the channel is ideal, the station can send the data to the channel. Otherwise, it must wait until the channel become available, until the channel become free, until the channel become ideal. Okay, so hence it reduces the chances of the collision on the transmission medium. So it's reduce the chances of the collision on transmission medium because we are polling the channel, we are sensing the channel, whether the channel is free or not. If the channel is free, then we are sending the data. Now here, let's see the CSMA access modes. There are different CSMA access modes are there. First one is the one persistent mode. Now what is this one persistent mode? So in the one persistent mode of the CSMA, it defines each node first sends the shared channel, and if the channel is ideal, and it immediately sends the data. Okay, first the station will sense it. If the channel is ideal, then the data will be sent by the stations. as it must wait and keep the track of the status of the channels to be ideal and broadcast the frame unconditionally as soon as the channel is ideal. So you can see in this figure, the station is continuously sensing the channel is busy. When it senses the channel is free, immediately it will transmit the data. So this is what the one persistent. Now see, a second CSMA access mode is what? Non-persistent. Now what is the meaning of non-persistent? So it is the access mode of the CSMA that defines before transmitting the data, each node must sense the channel, and if the channel is inactive, it immediately sends the data. Okay, so otherwise the station must wait for a random time, that is non-continuously. Random time, random number will be selected for waiting. Okay, and when the channel is found to be ideal, it transmits the frame. Okay, so here it is not continuously sensing. Here it will just define one random number. According to that random number, it will just sense the channel, and if the channel is free, then it will send the data. So here you can see, first the station is sensed, the channel is busy, so again it will wait for a random number. After the random number completes, again it will sense the channel is busy, again it will wait. And after that, it finds that channel is free, so after that it will send the data. Now next is the P persistent. Now what is this P persistent? It is the combination of the one persistent and the non-persistent modes. Okay, so the P persistent mode defines that each node senses the channel, and if the channel is inactive, it sends the frame within the P probability. Okay, so that's why here it is known as the P persistent, because we are taking in consideration the probability. If the data is not transmitted, it waits for a Q is equal to 1 minus P probability, random time, and resumes the frame with the next time slot. So now here you can see it is continuously sensing, because it is the combination of the one persistent and non-persistent. Okay, one persistent, that means it is continuously sensed, and probability, after that it will find the channel free, again it will wait for the probability time, and if the channel is still free, then it will transmit the data. Now next is the CSMACD, that is Carriersense multiple access with the collision detection. So here it is network protocol to transmit the data frames. CSMACD protocol works with the medium access control layer. So therefore it first senses the shared channel before broadcasting the frames, and if the channel is ideal, it transmits a frame to check whether the transmission was successful or not. Or if the frame is successfully received, the station sends the another frame. Now, if any collision is detected in CSMACD, the station sends the jam or stop signal. Okay, so to the shared channel to terminate the data transmission. If any collision is detected, then only. After that, it waits for the random time before sending the frame to the channel. And the entire process of the collision detections can be explained in the diagram. Let's see. So here you can see, this is the diagram for the CSMACD. Okay, so here it will wait for the first the initialization, that is K is equal to 0. Now what is this K is equal to 0? K, that means the numbers of the attempts. Okay, how many times it will attempting this. Okay, so it will for that numbers of the attempts, first initialization that will be defined as a K is equal to 0. So apply one of the persistent method, that is one persistent, P persistent, or any persistent method, and it will check for the whether the channel is free or not. Okay, so if the transmission done or any collision detected, then what will happen? If any collision detected, again it will come here at the downside and we'll see the collision is detected. If yes, then it will send the jamming signals or anything. Okay, and K is equal to K plus 1, because we are increasing the numbers of attempts, that's why. And if the numbers of attempts limit is reached, okay, so if numbers of limit is reached, then it will abort, and if it is not reached, it will try again. Okay, and if no collision is there, then it will transmit and receive the data. Okay, so this is the working of the CSMACD. Now in the CSMACA, It's Carriersense multiple access collision avoidance network protocol for a carrier transmissions of the data frames. So it's protocols that works with the medium access control layer. When a data frame is sent to a channel, it receives an acknowledgement to check whether the channel is clear or not. Okay, so it will receive the acknowledgement. If the channel is clear, it will send the data, otherwise it will not send the data. Got it? If the station receives only a single on acknowledgement, that means the data frame has been transmitted to the receiver. Okay, so this is very simple. If the acknowledgement is received, then data is sent. Now, but if it gets the two signal, its on and one more in which the collisions of the frames. So a collision of the frames occur in the shared channel. If it will get one more acknowledgement, that means the collision is there. So that detects the collision of the frame when the sender receives an acknowledgement signals. So following are the methods that is used in the CSMA to avoid the collisions. Which are the method? So first one is the InterFrame Space. Now what is the meaning of this? In this method, the station waits for the channel to become the ideal, and if it gets the channel is ideal, it does not immediately send the data. Instead of it, it will wait for some time, and this time period is known as the InterFrame Space, or in short it is known as the IFS. So it will not immediately send data, it will just wait for a particular time, that is known as the IFS. Then next one is the contention window. Now what is the contention window? In the contention window, the total time is divided into different slots. Okay, timing is divided into different slots. So when the station or sender is ready to transmit the data frame, it chooses a random slot number of the slots, that is known as the wait time. If the channel is still busy, it does not restart the entire process, except that it restarts the timer only to send the data packets when the channel is inactive. Okay, so in contention window, your entire time is divided in the different time slots. According to that time slots, the station will wait if this channel is busy. Then last one is what? The acknowledgement. So in the acknowledgement method, the sender station sends the data frame to the shared channel if the acknowledgement is not received ahead of the time. Now let's see how the CSMA works. Okay, what is the working process of the CSMA? We have learned the three different methods: IFS, InterFrame Space, Acknowledgement, etc. So let's see how it works. So we are seeing it in the form of the diagram. So first of all, the start step is there, and after that we have initialized k is equal to 0. This k means it is the numbers of attempts. Okay, so here first k is 0, and after that it will check whether the channel is ideal or not. Okay, so if the channel is not ideal, then it will wait continuously. But if it will find that that channel is ideal, so what will happen? It will wait for the IFS frame. IFS, that means InterFrame Space. So it will wait for the IFS frame, and after that again it will check. Still the channel is ideal. So if the still channel is not ideal, then again it will go back and it will wait. But if this channel is ideal, then it will choose a random number between, that is 0 to 2 raised to k minus 1. Okay, and after that it will wait for the R slots that is defined, that is chosen using the R number. Okay, and it will wait for that time, and after that it will transmit the data. After transmitting the data, it will wait for the timeout, that means data is sent, and the acknowledgement should be received by the station. If acknowledgement is not received, the data is not received by the receiver, or it may be happen any collision is there. Okay, so station will wait for that particular acknowledgement. So if the acknowledgement is received, that means what? The data is successfully transferred. But if the acknowledgement is not received, then after that what? So if the acknowledgement is not received, this k is increased, that is k is equal to k plus 1, that means numbers of attempt is increased. If the numbers of attempt is reached to its limits, then the station will abort this transmission. And if it is not reached to its maximum limit, then again it will do the same process. Got it? So like this way CSMA will work. So in this video we have learned about the CSMA protocol. That is a Carriersense multiple access protocol, in which we have seen the three different access mode: one persistent, P persistent, and non-persistent. And we have learned this different variation of the CSMA, that is CSMACD, that is Carriersense multiple access with the collision detection, and the Carriersense multiple access with the collision avoidance. So thank you for watching. We will meet in the next lecture with a new topic. Thank you.